this video, we're going to start going over 8.6, which is phase changes. So please pause if you have to, but make sure you have your practice packet out. This is on page 8, and I would like you to follow along as we complete this chart. Okay, so in this word bank here, we have 6 of the different phase changes that we can have between solid, liquids, and gases. So make sure you get 2 different colors, okay? So I'm using blue and red, but they can be whatever colors you like. Just make sure you label accordingly. So for this, I am going to draw all of my exothermic changes in blue and all of my endothermic changes in red. Okay, so first let's go over again what endothermic and exothermic are. So endothermic means energy is being absorbed. And that capital E just represents energy. Oops. And exothermic means that energy is being released. So releases energy. Okay, so all these phase changes are going to either absorb energy or release energy in order to get to some different phase. So in this chart, we have, starting out on the left, we have solids going to liquid to gas. Okay, notice how for the solids, all of those particles are really, really close together. Okay, it's important that you remember that for a solid, the particles are going to be really, really tightly packed. Another way we can say this is that they have more order or less disorder. Okay, disorder meaning not ordered. Okay, this just means that they're arranged in this tightly packed configuration, and they are not random. Okay, so they're really tightly packed and aligned, so we can say that solids are more ordered or less disordered. Then you go to your liquids, and the particles are going to be a little bit more spread apart. And then until we get to our gas, where the particles are going to be the farthest away apart. Okay, and this is where they're going to have the most disorder or more disorder, which is the same thing as saying that they are less ordered. Okay, there's more randomness. They're random. Okay. So let's just start out with going from solid to a liquid. So when a substance transitions from a solid to a liquid, we would call this melting. Another term for melting that you can sometimes be seen is also called fusion. Okay, so think you have an ice cube sitting out on the table, and after a while, that ice cube is going to start melting down. Okay, I actually have a little ice cream. Okay, so a solid to a liquid is melting or fusion. Okay, and this is our first endothermic process. Now for F, we go from a liquid to a gas. We would call this evaporation. Sometimes it can be called vaporization or even boiling. Okay, imagine you're boiling a pot of water to put your pasta in. Okay, so boiling would be that substance is going from a liquid to a gas. And okay, so the picture I have here is from some sort of hot spring, and that liquid water in that lake is evaporating into a gas, into water vapor. Okay, so what about H here? So what happens if we go right from a solid straight to a gas? Now, this is what we call sublimation. So a substance will skip over the liquid phase completely and go right from a solid to a gas. Now I'm going to put a star because two really, really common examples that you might see often are when solid carbon dioxide sublimes into gaseous carbon dioxide. And same thing with iodine, can do the same thing. Okay, so this picture I just added here. So this is a picture of dry ice. So dry ice is just actually solid carbon dioxide, and it's going to readily sublime or change from a solid to a gas at room temperature. Now this other example, here's a picture I have, is what iodine is going to look like when it sublimes or goes from a solid to a gas. Okay, and it produces this kind of cool purple vapor. Okay, so everything that I highlighted in red, these are the three endothermic phase changes, meaning that in order to go from a solid to a liquid to a gas, or from a solid to a gas, all of these processes are going to require energy to be absorbed. Okay. And think about it, it kind of makes sense. So your solid is going to be, the particles are closer together, they have lower energy. Now, if they want to break away from these intermolecular forces that are between those particles, they're going to need an input of energy. Okay, energy is going to have to be absorbed by that substance in order for these particles to have enough energy to break away from each other and break away from those intermolecular forces that are between them. Okay. Now, how about exothermic? Okay, so I'm going to do this one in blue now. So let's start here at D. So as we go from a liquid to a solid, this is freezing. Another term for freezing is solidification. Okay, so solidification has the word solid in it. So just think of a liquid is going to be freezing into a solid or solidifying into a solid. Now the example I got is icicles. Okay, so water can drip down. Sometimes they are like hanging from your house. Water is going to drip down, and because of those really cold temperatures, that water that's dripping is going to form an icicle. Okay, it's going to solidify into an icicle. Now G goes from a gas to a liquid. So when a gas turns into a liquid, we call that condensation, or that substance is condensing. So you've probably experienced condensation if you take like a cold water bottle outside on a hot day. Eventually, the water vapor in the air is going to condense down into these liquid beads that are on your water bottle or sometimes on a glass that has some sort of beverage in it. Okay, so that leaves us with the last one, I, which is deposition. So going from a gas to a solid. The example I have for that is frost. So if you ever went outside when it was kind of during a colder winter month and there was some frost on your grass or there's frost on the car windshield. Okay, so this is when water vapor in the air is going to go through deposition, okay, where it's going to turn into a solid and form that solid frost on whatever surface. So this picture I have here is on frost on a leaf. Okay, so these three now, so we're almost like we're going in reverse from gas to liquid to solid. As we go from a gas phase where there's more disorder, all of these particles are super, super far away from each other. And when we want to kind of push those particles back closer together until we get to this solid where the particles are really, really close, that's going to be an exothermic process. So these substances need to release energy in order to kind of come back down into that more stable, lower energy solid phase. Okay, so for solids, you want to think of them as having less energy and your gases as having more energy. Okay, remember when we looked at how these particles are moving. So for a solid, they are not moving, okay? They're going to have some motion, but they're only going to be vibrating around in that substance. They can't really move around too much, but they will be vibrating a little bit. So they do have a little bit of energy. Now, as we go from a solid to a liquid and then even to a gas, they're going to gain more and more energy. They're kind of going to be flying all around. Okay, so once our particles go from a place where they're really tight together to being really far apart, these particles need to absorb energy in order to overcome the intermolecular forces that are trying to keep them together. Now, if we're trying to get these particles that are super, super far away, like a gas, and push them together so they're closer like a solid is, that substance is going to need to release that energy back out. Okay, so this is the 6 different phase changes that you need to know. It is super duper important that you know which ones are endothermic or require the absorption of energy and which ones are exothermic or release energy. I kind of like to look at it in this way. So if I am trying to work on my test, I'll write out solid, liquid, gas from left to right. And I know that when I go from left to right, that's going to be endothermic processes. Energy needs to be absorbed. And as I go from right to left, those processes are going to be exothermic or require the release of energy. Okay, so however it helps you to remember, that's something that helps me though.